Hey, good morning. This is going to be a slightly different tone as far as a talk goes. I'll try to talk into this thing. This is largely based on some of my experience throughout my career. Most of us in this room are achievement-oriented folks, higher education, degrees, research, and so forth, wanting to share our ideas with others. And I'm no different. But because we're of that type, we tend to realize that early on we're dealt a certain hand, certain strengths, and so forth that we use to take us maybe well into our 20s, and we focus on those strengths and have them take us as far as we can go. But at some point we realize to go further we have to start working on our weaknesses and identify those weaknesses. And it was around that time that I was going into my doctoral program, and it was a multidisciplinary doctoral program at SUNY Albany, State University of New York at Albany at that time. They drew from faculty it was centered in the business school, but drew from public administration, sociology, psychology, and so forth. And so a lot of different areas you could draw upon for your research. And at that time, I had already been well versed in understanding the Myers-Briggs cognitive style typology, and based on Carl Jung's book, Psychological Types. So I already knew at that time that I was an INTP, so I knew that there were certain ways that made me good at certain things. Armchair theorizing, yes, I can make assumptions, can read theories, find ways to think about new possibilities and so forth, but I also knew it was a real weakness, that my weakness was that I'd be too much of an armchair theorist. I wouldn't get there into the actual things themselves, and that can be a real problem. And so actually at that time, consciously, I chose research methodology of ethnography. Had a professor that was very influential in pushing me in that direction, and I realized, yes, what I need as an INTP is real data. I don't need to just read theories and try to find cross-pollination across theories. What I need for my cognitive type is real data that I can synthesize something new from. So I did a dissertation where I worked at General Dynamics at the time, and was able to come up with some interesting findings, I believe, that turned into a journal article and so forth, that brought forth a phenomenon that I would have never achieved or realized or come upon if I had just sat there reading books and so forth. So I was actually going out to the people, interviewing them, excuse me, taking field notes for a long time. It's not the most time-efficient method of research, but my point is that along that way, and since then, I've come across certain literature, certain things that sociologists or psychologists or philosophers have said that help remind me of what those weaknesses are. And I think some of these, I'm basically going to be using quotations from 4 different thinkers that I think over the last 10, 15 years have just really struck me as keep helping to remind me of some of the things that I have to be aware of and caution me in terms of thinking and theorizing and researching and so forth. So that's kind of what this talk is going to be about, mainly other people's voices, but a chorus of the 4 voices coming together I think are going to help remind us as researchers that we often make a lot of assumptions about the world. We theorize a lot, and sometimes that oversimplifies the world in ways that I know that, based on some of these quotations I'm going to be sharing with you, I realize is not always the best thing to do. So starting with, I mentioned Carl Jung before, famous psychiatrist. This is one of my favorites, by the way. This is from his memoirs. He wrote an autobiography, Memories, Dreams, Reflections. And this is just a fairly long quote from it, but I find it always tickles me when I read it. Okay. He said, "School came to bore me. It took up too much time, which I would rather have spent drawing battles and playing with fire. Divinity classes were unspeakably dull, and I felt a downright fear of mathematics class. The teacher pretended that algebra was a perfectly natural affair, to be taken for granted, whereas I didn't know what numbers really were. They were not flowers, not animals, not fossils. They were nothing that could be imagined, mere quantities that resulted from counting. To my confusion, these quantities were now represented by letters, which signified sounds, so that it became possible to hear them, so to speak. Oddly enough, my classmates could handle these things and found them self-evident. No one could tell me what numbers were, and I was unable even to formulate the question. To my horror, I found that no one understood my difficulty. The teacher, I must admit, went to great lengths to explain to me the purpose of this curious operation of translating understandable quantities into sounds. I finally grasped that what was aimed at was a kind of system of abbreviation, with the help of which many quantities could be put in a short formula. But this did not interest me in the least. I thought the whole business was entirely arbitrary. Why should numbers be expressed by sounds? One might just as well express A by apple tree, B by box, and X by a question mark. A, B, C, X, Y, Z were not concrete and did not explain to me anything about the essence of numbers any more than an apple tree did. But the thing that exasperated me the most of all was the proposition, if A equals B and B equals C, then A equals C, even though by definition A meant something other than B, let alone with C. Whenever it was a question of an equivalence, then it was said that A equals A, B equals B, and so on. This I could accept, whereas A equals B seemed to me a downright lie or fraud. I was equally outraged when the teacher stated, in the teeth of his own definition of parallel lines, that they meet at infinity. This seemed to me no better than a stupid trick to catch peasants with, and I could not and would not have anything to do with it. Carl was a pretty smart guy. It wasn't because of his lack of intelligence that he had this issue with algebra. It was because he was very sensitive to the fact that as soon as you go there, you're making a metaphysical leap. You're making a metaphysical assumption of equivalence of things. And he didn't make him comfortable. He wasn't comfortable with it. You know, when we talk A equals oranges, B equals apples, whatever, we're making a pretty profound metaphysical assumption about their ontology, that they share some properties with each other that are helpful for us practically. You want to go to the store and buy 10 apples or something, but ultimately, and I think where his difficulty came from, ultimately they differ from each other in some way. Time and space, their configuration of atoms and molecules, and at some point, 2 apples next to each other or 2 pens or whatever are completely different from each other as far as unique entities in the world. So I think that's part of where he was getting at, that Platonic tendency of ours to think of abstractions, to think of generalizations of properties of things, the extrinsic properties that was in the title. And not that there's anything wrong with that, right? But it becomes a problem if we do too much of it, and we do it recklessly. And I'll talk about Heidegger in a moment, but it tends to permeate our way of thinking and approaching the world and seeing the world, framing the world, as I'll get to in a second. But even when it comes to physics and engineering, I was lucky enough to work at General Dynamics in Pittsfield, Massachusetts, with their guidance systems department, the D5 guidance system that's launched from the Trident IIs. And you know, most of the things we cobble together engineering-wise are pretty straightforward. They have processors, they have communications, they have applications, and they run pretty well. There might be some reliability issue or something might go, but they're designed to be functional in certain ways. These systems instead are extremely high accuracy. They use gimbals, gyros, things like that have incredible accuracy. But the real world is nonlinear. You take a systems engineering course and you learn about how various systems, if you look at them in a linear way, behave predictably, but in reality, nothing is really linear. There's nonlinearities everywhere. And in order for these guidance systems to work, even though each guidance system used the same components, the same sensors and so forth, each of them had to be calibrated with, I think it was close to 100 calibration coefficients. So even though you have functionally similar pieces in there, you want to call them, you know, the gyroscope or this and that, you know, 3 different gyroscopes. Ultimately, there's differences that you have to take into account from an engineering point of view, if you're going to want that overall system to be as true and accurate as you'd like it to be. So yes, we have a tendency, especially with things that are designed to be modular and designed to be digital. We think of things as being equal, monetary systems and so forth. You know, they're not, monetary systems aren't, you know, a dollar isn't a dollar if you're having double-digit inflation or something like that. Over time, it can change in a way that is meaningful. But my point is, I think you get it, is that it's a tendency for us to go down that rabbit hole and make assumptions about things in the world as being equivalent to each other because of their function, when in reality they're not, and sometimes they're not in a meaningful way. That brings me to Heidegger. How are we doing on time? Okay. Martin Heidegger wrote Being and Time, and afterwards he wrote The Question Concerning Technology, which is considered one of the classics in the philosophy of technology. Some say he over-romanticized some of the things, like with the Greeks, the ancient Greeks and so forth. But he told a very powerful story in that rather short essay, where he said, not only is this tendency to make assumptions about objects or things in our world, not only does it have pitfalls, but it really permeates our overall way of thinking about our world and each other, that he thought had certain dangers that he wanted to sensitize us to. And of course, this was happening around the World War II, I believe it was, so he was seeing things that were rather dire in their results. So part of it came from trying to explain why some of that was happening. So a few quotes from him. He uses the word enframing to get at this way of looking at the world as a kind of reductionist way. So the rule of enframing, which demands that nature be orderable as standing reserve, hence physics, in all its retreating from the representation turned only toward objects that has alone been standard till recently, will never be able to renounce this one thing, that nature reports itself in some way or other that is identifiable through calculation, and that it remains orderable as a system of information. So he's saying that's the way we try to approach the world. But enframing does not simply endanger man in his relationship to himself and to everything that is. As a destining, it banishes man into that kind of revealing which is an ordering. Where this ordering holds sway, it drives out every other possibility of revealing. And part of his story, if you read his whole article, is that he felt that the Greeks really had a different way of ordering or creating things or bringing things into being that were, I guess, a little more creative. The threat to man does not come from the first instances from the potentially lethal machines and apparatus of technology. The actual threat has already affected man in his essence. The rule of enframing threatens man with the possibility that it could be denied to him to enter into a more original revealing and hence to experience the call of a more primal truth. Okay, that sounds pretty lofty. But the point is that he's saying that this way of thinking tends to blind us or conceal certain ways that things are that need to be also factored in our thinking. To keep closing off the world, looking at it as a resource at hand, and so forth. And he was really disturbed in particular, and he even says it right in the essay, the term human resources. He's just like that sort of was taking all of this and saying, now we're framing each other. We're looking at each other as mere resources and not as something more than that. So that was a bit of a problem for him. I'm doing pretty well on time. Okay. So that's kind of lofty stuff. And I think we can agree that based on our modern world and the world that we're dealing with and the devices that we use to communicate and the things we use in our research have some of these constraining, concealing properties to them. I've also been getting into the philosophy of consciousness a lot lately, so some of this is going to steer now in that direction, that in these systems that we're studying, often a node in the system is a human being that is conscious, and so we've got to make sure that we understand what that means, My previous talk yesterday, I got into some of the ways in which the mind can do semantic things, operations, context-based thinking, and so forth. And more science and philosophy are really realizing that consciousness is something we don't really understand. We don't know what it is. It's been a big deal in the last 20 years because some of the philosophers have really posed what's called the hard problem of consciousness. David Chalmers, I'll talk about him in a second too. But he said what the really hard problem is the problem of experience. There's something it is like to be a human being, to be a creature, to see the color red, to imagine an Eiffel Tower or something like that. That science, and from measurement, you can't put probes in somebody's brain and say they're having a red experience or knowing what that red experience is like. So that intrinsic side of us as human beings, and oftentimes human beings that are subject to the studies or the simulations or the variables that we're using in our research, shouldn't be reduced or too much, I guess is my point. We shouldn't make overly simple assumptions about what they are and what they can do. So Karl Popper, way back when he wrote his book Objective Knowledge, really started to see consciousness as something really important. And he talks in that book about how conceivably chemistry could be reduced by physics. Everything that happens in chemistry could be explained potentially by the laws of physics. And so he's called that a reduction. But he said that consciousness would never be able to be reduced by physics or other theories because he calls it an emergent property in the universe. And Karl Popper is, he's father of positivism and falsifiability and stuff like that. He really put quite a bit of thought into it, and quite a bit of that book is dedicated to this thought that he really thought there was something unique about consciousness, and that these other researchers did as well. Like Thomas Nagel, have you heard of Thomas Nagel and his essay, What It's Like to Be a Bat? That was really what started the new wave of looking at consciousness as something unique, and that David Chalmers later took and called the hard problem. And thinking about what it is like to be a bat, we would never know. They use echolocation to find their food and fly around and sense things. So his point was we can never know what it's like to be a bat, and we can never know what it's like to be another person either. We don't know that what you see as red looks like green to me. Things like that you can never know. So it became a challenge to physics and philosophy to say, explain this phenomenon of what it is like to be something from a physics and scientific point of view, and really you can't. I mean, it's basically it's an ontology that they're still saying just is a mystery, and I find that very exciting to think about. And so Nagel later, in a more recent book called Mind and Cosmos, really thought about, given the world of physics and modernity and how we think physics and engineering and everything is going to explain everything for us. He says, no, there's consciousness in there too, and we have to factor it in or think about how it's got a unique place in the world. So he says the great advances in the physical and biological sciences were made possible by excluding mind from the physical world. This has permitted a quantitative understanding of the world, expressed in timeless, mathematically formulated physical laws, but at some point it will be necessary to make a new start on a more comprehensive understanding that includes the mind. And that poses the question, to what extent will the reductive form that is so central to contemporary physical science survive this transformation? So how is it going to actually try to incorporate the concept of mind into its whole world? And then he talks more specifically about what really is intrinsic properties and how we have to think about them. He says, or consider the different conjunctive explanation in the case of the pocket calculator. A is the physical explanation of what happens when I tap in 3 + 5 =, which causes B, the display on the screen of the figure 8. It is a further fact that this figure is the symbol for the number 8, and the figures I tapped in are the symbols for a certain sum. So we have the consequence C that the device produced the right answer for the sum entered. But without more, this is merely an assertion and not yet an explanation why the calculator gave the answer. Without the further fact that the calculator was designed to embody an arithmetic algorithm and to display its result in Arabic numerals, the physical explanation alone would leave the arithmetical result completely mysterious. So there's something going, there's a design in that thing that is behind its production of its output. There's an input and an output, but there's an algorithm in there that's designed in that needs to be understood. So again, when we think about consciousness or about almost anything in the world, it's that emphasis that there are intrinsic properties to it that need to be understood. Still doing okay on time? Yep. 5 minutes? Okay, perfect. So with that, I forgot to show Thomas. There's Thomas. What is it like to be a bat guy? And now David Chalmers, who really wrote the book in '96, The Conscious Mind, that is a great read, grappling with the problem, showing exactly why consciousness is such a difficult thing for philosophy and science to deal with. But here's just a few quotes from him. Physics tells us nothing about what mass is or what charge is. It simply tells us the range of different values that these features can take on, and it tells us their effects on other features. As far as physical theories are concerned, specific states or mass or charge might as well be pure information states. All that matters is their location within an information space. So he's saying to physics, that's all that matters. This is reflected in the fact that physics makes no commitment about the way these states are realized. Any realization of these information states will serve as well for the purposes of a physical theory, as long as it maintains the correct structure of causal or dynamic relations between the states. After all, as long as the shape of these relations is the same, physics will look the same to our perceptual systems. We do not have access to any further properties of the realization in the external world over and above the shape of the causal network. He's saying, if we were just studying a human being, for example, from the outside, we could get certain information about their brain and what the brain's doing, but that's extrinsic information that can explain a lot, but not everything. And so when it comes to consciousness, he's really saying the ontology that this leads us to might truly be called a double aspect ontology. Physics requires information states but cares only about their relations, not their intrinsic nature. This view postulates a single basic set of information states unifying the two. We might say that internal aspects of these states are phenomenal and the external aspects are physical. Or as a slogan, experience is information from the inside, physics is the information from the outside. So my whole point is to realize there's things on the inside, whether it's a conscious creature or some kind of other kind of an object we're looking at, an apple or an orange or a pen, that they're not necessarily equal to each other. Just because they satisfy certain relations and information states doesn't mean we fully understand what they are, and we should always be cautious about making assumptions, especially with things like modeling and simulation. We tend to, and I'm guilty of it myself, I've done plenty of it in the past, you tend to oversimplify things, and it makes your simulation work great, but it doesn't necessarily map onto the real world very well. And that's all I have today. Thanks.